A large language model on its own is just a very smart chat partner. It can answer and it can reason, but it can't act. So what actually turns it into an agent, one that plans, uses tools, and gets real work done? It comes down to 5 pieces. 5 terms you need to know about agentic AI. Let's start inside the agent. At its core sits the language model. That's the reasoning engine. But a raw model just talks. What turns it into an agent is the layer of instructions wrapped around it. And that layer is where our first 2 terms live. Term 1, agents.md. The .md simply means Markdown, a plain text file that sits at the root of your project. Think of it as a README, but written for the agent instead of a human. It spells out what the agent needs to know every time it works here. Which command runs your tests, which code style to follow, how a pull request should be named. When the agent starts, it reads this file and obeys it, and it can be nested. A file at the root and more inside subfolders where the closest one wins. Agents.md came from OpenAI and is now an open standard under the Linux Foundation. One quirk: some agents use their own name. Claude, for instance, reads Claude.md, but the idea is identical. Agents.md is read every single time, but some knowledge the agent only needs once in a while. Loading all of it every time would just waste the context window. That's term 2, an agent skill. A skill is a folder holding a file called skill.md, plus any scripts or resources the task needs. Inside, a short description tells the agent when to reach for it. Invoke me when the user wants to do this. If the request matches, the skill is pulled in. If it doesn't, it sits quietly, costing nothing. It's an open standard and it works across multiple platforms, so agents.md shapes how a project works, and a skill teaches the agent a specific job. Our agent now knows what to do. But real work means reaching outside itself to APIs, databases, developer tools, whole SaaS platforms, and every one of those speaks its own language. Without a standard, you'd hand-build a connector for every tool an agent might touch. That's the problem term 3 solves. MCP, the Model Context Protocol. It's an open protocol that connects AI applications to tools, data, and workflows. It ships with an MCP server that wraps a tool behind one common interface. Learn to speak MCP once, and an agent can reach anything. Notion, a Stripe link, your own database. The agent talks to the server, and the server handles the messy API underneath. MCP began at Anthropic and now has broad industry backing. That covers agents talking to tools. But what about agents talking to each other? Term 4, a 2A agent-to-agent. It's an open protocol for agent-to-agent communication. Picture a procurement agent that handles contracts and a finance agent that approves spend. The procurement agent closes a deal, then needs sign-off. Without a standard, they'd need a custom bridge. With a 2A, each agent publishes an agent card, a short profile of what it does and how to talk to it. Other agents read that card and know exactly how to delegate. A 2A comes from Google, and it too is an open standard under the Linux Foundation, so the agent knows what to do and how to reach out. But sometimes one agent simply isn't enough. A task can be too big for a single context window. Reviewing a code base with thousands of files would overflow it. Or the work is naturally parallel, 20 independent checks that you'd rather not run one by one. That's term 5, sub-agent. The main agent spawns child agents, each in its own fresh context. A child does one job, say read 500 files and return a summary, then hands the result back, keeping the parent's context clean. And you can run many at once, 20 agents, 20 checks in parallel. There's no formal standard yet, but the pattern looks the same everywhere. A parent spawns children. Each gets its own context, does its work, and reports back. So there are your 5. Agents.md and agent skills live inside the agent and shape how it behaves. MCP and A2A reach outward to tools and to other agents. And sub-agents handle the work that won't fit in one context. Put them together, and that's what a frontier AI agent really looks like under the hood. And this isn't just theory. At PaperOffice AI, these building blocks are already running. An MCP server exposes real document tools, AI-OCR, intelligent document processing, and three-way matching to any agent that speaks the protocol. And sub-agents work through your documents in parallel, reading, extracting, matching, and acting all on their own. The building blocks of Agentic AI put to work. See it for yourself at PaperOffice AI.